Supplemental math videos from Circle Christian School.
The difference quotient, reaching the limit. First the limit's there, then it doesn't exist, and it can be indeterminate form, but then we can change it all around so it does exist. Kind of crazy. These are the notes from class. When we substitute into a limit, we're just basically evaluating and giving a value of what y is. Remember, as a number, as x approaches a number, what we're looking for is what the y is. So in the first case here, as x approaches 2, y would be -4. Well, we know that looking at the next problem that -3 would be something that we can't put in there, but we know it's far enough away that we could put x as it approaches 2, which we find is 0. And we look for the asymptote. Nope, I did it again. Oh well. And it's continuous at this value. If we use a little bit of cancellation in here, putting in the value that we know it can't equal, and we get 0 over 0, we know that factoring somehow is involved. You can try a few, see what you get, but notice that when we do the factoring and we put 2 in, we do get a y value. But wait, I thought you could not have a value because there's an asymptote. Putting in the limit here again gives us with the 0 over 0, so we know there's a factoring situation here, and we can use the fact that x minus 1 must be one of the factors, so we can use synthetic division to divide it out. And once we get to the factored form, we can put the 1 in and find that it's at 1/2. Always look for the opportunity for cancellation, but to do so you must determine that 0 over 0 before you can do any canceling. There are times where if you put something in, you're not even going to get the 0 over 0, but totally undefined, and that's where you find the limit does not exist. We can also use rationalizing to manipulate some of our limit answers and to help us with a little bit of factoring. For instance, as we look at the first one, we know x would be approaching 0, and if we put it inside, we do see that we get that 0 over 0, so we can do some factoring, and with a radical you can remember to do the little conjugate thing. Other times with some manipulation we can work on a complex fraction and bring out the factoring so that we can have a value for our limit. Now this is where the difference quotient comes in. Remember, the difference quotient was derived from the fact that we have the slope, the difference of the y's over the difference of the x, thus the difference quotient. Using the difference quotient, we can actually go find slope. Slope is also the rate of change. If we have a straight line situation, it's pretty easy to see how far up and down and how far back and forth. However, with something like a parabola or any type of curve type thing, the rate of change is constantly changing, depending on where you're looking at the parabola. But we can make a calculation at a certain point. We can always make a bit of an approximation. We can make a best fitting line by using a secant line and getting that secant line as close as we can to 2 points. Finding the slope at a particular target point. I'm sorry, at a particular tangent point. What is tangent? Well, of course, tangent is where it hits at just 1 point. So we can actually find what the slope is at any given point on a type of a curve, especially a parabola. We can put the point in and find a slope based on what point we're using, but it seems like we can make a generalized something to be able to use with all points that are on the parabola instead of just putting every single one in to go find what kind of slope is happening. Once we do that, we can use what we have to find the equation of the tangent line by using our point slope formula. So let's find the slope of f of x when x squared minus 3 at the point 2, 1. Using our difference quotient, we find that we end up with a slope of 2x. Then we can go find the equation of the line because all you need is a point and you need a slope. Okay, so I don't have my little pen with me here, so I'm having to use my mouse, so it's going to be a little ugly, but you get the idea. And so I'm going to put our point and I'm going to put our slope in. Our slope is 2. And we're doing the point at 2, 1. So the 1 is the y. The 2 is the x. Whoop. And we're just going to distribute, mix things around. Draw, that's how you make cake. And now we're going to add the 1 and the equation of the tangent line at the point 2, 1 of the parabola is 2x minus 3. And there you've got it. It's all yours.